Hello there, and welcome to Simple Science for Sleep. As you read these words right now, you're traveling through space at 67,000 miles per hour. You can't feel it. There's no wind in your hair, no rush of motion, no sense of movement at all. Yet you're spinning with Earth, orbiting the Sun, spiraling through the galaxy, all while the galaxy itself races through the cosmos. And somehow, in all this motion, you feel perfectly still. Tonight, we're drifting somewhere special. A place so vast, it holds everything you've ever known and everything you'll ever dream of. This is your universe, and it has the most beautiful secrets to share with you. Before we begin this journey together, if these quiet explorations of science bring you calm or spark your curiosity, hit that like button and subscribe so you don't miss more amazing cosmic stories tomorrow. And I'd love to know. Leave a comment telling me where you're watching from and what time it is there. There's something beautiful about knowing we're all under the same vast sky, scattered across the globe, sharing these moments of wonder together. It connects us in a way that feels almost cosmic. Now, let yourself sink into comfort. Adjust your pillow. Let your shoulders drop. Take a slow breath in and let it out even slower. Good, because what we're about to explore together isn't just information. It's an invitation to see yourself differently, to understand your place in this ancient, expanding, infinitely patient universe that's been working for billions of years to create this exact moment. You are not separate from the cosmos. You are not a visitor here, not a stranger passing through. You are the universe experiencing itself, a way for all this vast emptiness and explosive energy to know that it exists. And that journey, that incredible transformation from nothing to everything to you, began a very long time ago. Think about this. Every part of you, every cell, every atom, every tiny piece that makes you who you are, has a history. And that history doesn't start with your birth, or even with your parents, or their parents. It goes back further than any family tree could ever reach. It goes back to a time before Earth existed, before the sun burned, before our galaxy had even formed its spiraling arms. The carbon in your muscles, the oxygen in your lungs, the iron flowing through your blood right now, all of it was created inside ancient stars. Not this star, not our sun, but stars that lived and died billions of years ago, long before our solar system was even a thought in the cosmos. These weren't just any stars either. They were massive, powerful, burning bright and hot for millions of years. And then, when their fuel ran out, they didn't simply fade away quietly. They exploded. These explosions, called supernovas, were so powerful they outshone entire galaxies. And in those final, brilliant moments, they scattered everything they'd created across space. All those elements, forged in stellar fire, went flying outward into the darkness. That's where you came from. You are made of ancient starlight, the remnants of cosmic violence transformed into something gentle, something alive, something capable of wonder. This peaceful journey we're on together has been happening since the very beginning. Every atom in your body came from inside a star that exploded billions of years ago. Not metaphorically, not poetically, literally. The very substance of you was once burning at temperatures so extreme they would vaporize anything we know today. And now, those same atoms form your fingertips, your eyes, the thoughts moving through your brain as you take this in. Stars are like cosmic kitchens. For millions of years, they cook up elements, fusing lighter atoms into heavier ones. Through pure heat and pressure, hydrogen becomes helium. Helium fuses into carbon. Carbon transforms into oxygen. The process continues, building heavier and heavier elements, each one requiring more energy, more heat, more time. This is how stars spend their lives, as patient alchemists turning simple elements into complex ones. But stars can only do this for so long. Eventually, the biggest stars run out of fuel, and when they do, gravity takes over. The star collapses inward with tremendous force, then rebounds in a catastrophic explosion. This is a supernova, one of the most powerful events in the universe. For a few weeks, a single dying star can shine brighter than billions of normal stars combined. It's beautiful and violent and absolutely necessary. Because it's in those final explosive moments that the heaviest elements get created. The gold that might be in a ring on your finger, the silver in electronics, the iodine in your thyroid. These elements only form in the heart of exploding stars. They can't be made any other way. So when that star died billions of years ago, it sent all these precious elements flying into space, seeding the cosmos with the building blocks of everything that would come later. Our solar system formed from one of these ancient clouds, a mix of gas and dust that contained all the elements from previous generations of stars. Slowly, over millions of years, gravity pulled this material together. Some of it became the sun, some became planets, and some, eventually, became you. The iron in your blood, the element that carries oxygen through your body and keeps you alive, was forged inside a star. Every time your heart beats, you're circulating stardust through your veins. The calcium in your bones, giving you structure and strength, came from the same cosmic forge. You are literally held together by star matter. And it's not just the dramatic elements. The oxygen you breathe, the carbon that forms the backbone of every molecule in your body, the nitrogen in your DNA, all of it came from stars. You are not just in the universe, you are the universe. A small piece of it that has become aware, that can look up at the night sky and recognize its own origins. Think about that for a moment. The universe created stars, and those stars created you. There's no separation. You're not made of something different from the cosmos. You're made of the exact same stuff, just arranged in a particularly beautiful and temporary pattern that can think and feel and wonder. This means something profound. When you look at the stars, you're not looking at something foreign or distant. You're looking at family. You're looking at the furnaces that made you possible. Every star in the sky is a relative, a cousin in the great cosmic family that includes everything from galaxies to grains of sand to the person reading these words right now. You carry the universe inside you. Its history is your history. Its elements are your elements. And right now, as you rest here, those ancient atoms that have traveled billions of years through space and time are doing something they've never done before. They're being you. They're experiencing this moment of peace and wonder. They're coming home to awareness. But these atoms that make you didn't just appear in your body yesterday. They've been on the longest journey imaginable. Your atoms are older than Earth itself. They're about 13 billion years old, give or take a few 100 million. That means the physical material that makes up your body has existed since the universe was young, since the first generations of stars were just beginning to light up the cosmic darkness. These atoms have seen everything. They've witnessed the birth of galaxies, the formation of solar systems, the emergence of life itself. But here's what makes this truly beautiful. Before these atoms were you, they were other things, many other things. They've been part of clouds drifting through space. They've been locked in rocks deep underground. They've flowed through ancient oceans. They've risen as steam, fallen as rain, frozen in ice, and melted again. They've been absorbed by plants, eaten by animals, released back into the soil. They've cycled through the Earth's systems for billions of years, taking on countless forms. And they've been part of other people. This is not a guess or a romantic notion. It's simple mathematics. The Earth is a closed system. Atoms don't leave, they just move around, changing form but never disappearing. So, the oxygen molecules you're breathing right now, the ones filling your lungs and feeding your cells, those exact molecules have been breathed before, maybe by someone who lived 100 years ago, maybe 1,000. Maybe they were breathed by someone walking through ancient Rome, or standing on the walls of Babylon, or hunting in forests that no longer exist. You share atoms with every human who ever lived, with Cleopatra and Shakespeare and people whose names were never written down, with your ancestors going back not just generations but millions of years. The calcium in your bones might once have been in a dinosaur's bones. The carbon in your skin might have been part of a tree in a forest that existed long before humans walked the earth. These atoms are travelers, endlessly recycling, connecting everything that has ever lived into one continuous story. There's something deeply comforting about this. It means you're not isolated. You're not separate from history or nature or other people. You're woven into everything through the very substance of your being. The boundary between you and the world is much softer than it appears. Atoms flow in and out constantly. The air becomes you. Food becomes you. Water becomes you. And then, eventually, you become air and earth and water again, continuing the cycle. Right now, your body contains about 7 billion atoms. That's a 7 followed by 27 zeros. It's an incomprehensible number. But what's even more incomprehensible is that all of these atoms, every single one, has its own history stretching back to the beginning of time. Each one has been on a journey that makes your life look like a brief moment, a single breath in an endless conversation. And yet, despite being ancient, despite having been part of stars and planets and countless other beings, these atoms have never been arranged quite like this before. They've never formed you until now. This specific combination, this particular pattern that thinks your thoughts and feels your feelings, and experiences this moment is unique. It has never happened before in the entire history of the universe, and it will never happen again. So, you are both ancient and brand new, made of the oldest materials in existence, yet arranged in a way that's completely original. You're a bridge between the deep past and the present moment, between the cosmic and the personal, between the eternal and the temporary. And right now, as you lie here, these ancient atoms are doing something remarkable. They're not just sitting still, they're incredibly active, constantly moving, constantly working. Inside you, billions of chemical reactions happen every second, all in perfect harmony. Your cells are communicating, building proteins, breaking down food into energy, repairing damage, fighting off invaders, copying DNA, creating new cells to replace old ones. All of this is happening right now, beneath your awareness, in a symphony so complex that scientists are still trying to understand how it all works together so beautifully. Your body is constantly rebuilding itself. The cells lining your stomach get replaced every few days because stomach acid is so harsh. Your skin cells renew completely about every month. Red blood cells live for roughly 4 months before being replaced. Even your bones, which seem so solid and permanent, are constantly being broken down and rebuilt. Over the course of about 10 years, most of your skeleton gets replaced, atom by atom, cell by cell. This means you're literally not the same person you were a few months ago. The physical you is different. Most of the matter that made up your body last year is gone now, recycled back into the world, replaced by new atoms from the food you ate, the water you drank, the air you breathed. You're like a river, constantly flowing, constantly changing, yet somehow maintaining the same form, the same identity. And here's what's truly amazing. Your body knows how to do all of this. You don't have to think about healing a cut on your finger. You don't have to consciously direct your immune system to fight off infections. You don't have to remember to grow your hair, or regulate your temperature, or digest your lunch. Your body does it automatically, following instructions written into your DNA billions of years ago, refined through countless generations. This isn't random. This isn't chaos. It's the universe's intelligence expressing itself through you. The same laws of physics and chemistry that govern stars also govern your cells. The same forces that hold atoms together in distant galaxies hold the atoms in your body together. You're operating according to principles as old as existence itself. Principles that have been tested and perfected over billions of years of cosmic evolution. Even sleep, this state you're drifting toward right now, is part of this intelligent design. While you sleep, your body goes into deep repair mode. It clears out waste products from your brain, consolidates memories, releases growth hormones, balances chemicals, strengthens your immune system. Sleep isn't shutting down. It's a different kind of activity, just as important as waking, just as purposeful. Your heart keeps beating without you thinking about it, about 100,000 times each day, pumping blood through 60,000 miles of blood vessels. Your lungs keep breathing, bringing in oxygen and releasing carbon dioxide in a perfect exchange with the plants around the world. Your cells keep working, your atoms keep dancing, all in this quiet symphony that requires no conscious effort from you. You can trust your body. It's been doing this for as long as life has existed. It knows what it's doing. The same wisdom that built galaxies and formed planets is at work inside you right now, maintaining you, healing you, keeping you alive while you rest. You don't have to control it. You just have to let it happen. And this symphony inside you echoes a much larger rhythm playing out above. A rhythm that's been keeping time for billions of years. The moon is slowly drifting away from Earth, about 1.5 inches every year. That's roughly the same speed your fingernails grow. It seems impossibly slow, barely noticeable in a human lifetime. But over millions and billions of years, this gentle drift adds up. The moon wasn't always where it is now. Billions of years ago, it was much, much closer. Imagine Earth in its youth, maybe 4 billion years ago. The moon hung huge in the sky, appearing several times larger than it does today. It was close enough that its gravitational pull on Earth was far stronger than it is now. The tides weren't gentle risings and fallings of water. They were massive, dramatic events. Ocean waves towered hundreds of feet high, surging across the land twice a day with tremendous force. The Earth itself flexed and bent under the moon's powerful grip. And because the moon was so close, its gravity did something else. It acted like a brake on Earth's rotation. Back then, a day wasn't 24 hours. It was much shorter, maybe just 6 hours long. The sun rose and set 4 times as often as it does now. Everything moved faster, spun quicker, lived in a rhythm we can barely imagine today. But slowly, over enormous stretches of time, the moon's gravitational influence slowed Earth's spin. Day by day, year by year, millennium by millennium, our planet's rotation gradually decreased. Days got longer. 6 hours became 8, then 12, then 16. The process continues even now. Every century, the length of a day increases by about 2 milliseconds. It's tiny, but it's real, and it's been happening for billions of years. So the moon has been giving us longer days to live, more hours of sunlight, more time for life to grow and evolve, and eventually give rise to beings who could look up and wonder about that pale companion in the sky. Without the moon's patient influence, our days would still be short, our weather would be chaotic, our planet would wobble wildly on its axis. Life as we know it might never have developed. The moon has been our companion for 4.5 billion years. It's been there since Earth was young and violent, still being bombarded by asteroids, still forming its first oceans. It's witnessed every major event in our planet's history. The first single-celled organisms, the explosion of complex life, the age of dinosaurs, the rise of mammals, the emergence of humans. Through it all, the moon has been there, lighting our nights, pulling our oceans, stabilizing our world. And every night, it's still there, sometimes full and bright, sometimes a thin crescent, sometimes hidden entirely, but always present, always watching, always gently tugging at the waters of Earth, creating the rhythm of tides that countless creatures depend on for survival. There's something deeply comforting about the moon's constancy. It's been the same companion to every human who ever lived. The same moon that lights your window tonight also lit the windows of people thousands of years ago. They looked up at it and wondered, just as you do. They told stories about it, celebrated it, navigated by it. And billions of years from now, long after we're gone, the moon will still be there, drifting slowly away, patient and eternal. Just like the moon guides our tides, something else guides entire galaxies through the darkness of space. Most of the universe is made of something we can't see. Scientists call it dark matter, though it's not dark in the way we usually think of darkness. It's invisible. It doesn't interact with light at all. It doesn't emit light, doesn't reflect light, doesn't absorb light. You can't see it with any telescope ever built. And yet, it's everywhere, making up about 85% of all the matter in the universe. Think about that. Everything you can see, every star shining in the night sky, every galaxy photographed by our most powerful instruments, every planet and moon and asteroid and speck of dust, all of it combined makes up less than 15% of the matter that actually exists. The rest is this mysterious, invisible substance that we can only detect through its gravitational effects. It's like an invisible web holding galaxies together. Galaxies spin so fast that they should fly apart. The stars on the outer edges are moving so quickly that the gravity from the visible matter, the stars and gas we can see, shouldn't be enough to hold them in. They should escape, scatter into space, leave the galaxy behind. But they don't. Something is keeping them bound together. That something is dark matter. It forms halos around galaxies, huge spheres of invisible mass providing the extra gravity needed to keep everything in place. Without it, galaxies as we know them couldn't exist. The universe would look completely different. Stars would drift alone through space, never clustering into the beautiful spiral and elliptical galaxies we observe. Planets might never form because the clouds of gas and dust that create solar systems would never have enough gravity to collapse and condense. We're surrounded by this mystery. Dark matter passes through you right now, invisible particles moving through your body without touching a single atom, without you feeling anything at all. The Earth moves through clouds of it as we orbit the Sun. Our entire galaxy swims through an ocean of it. It's the hidden scaffolding upon which the visible universe is built. Scientists have been searching for dark matter for decades, building sensitive detectors deep underground, away from interference, hoping to catch just one interaction between dark matter and normal matter. So far, we've found indirect evidence everywhere, gravitational signatures that prove it exists. But we still don't know what it actually is. We don't know what particles make it up. We don't know its exact properties. It remains one of the deepest mysteries in science. And there's something beautiful about that. The universe isn't fully understood. It isn't completely mapped. There are still profound questions without answers, still mysteries that humble even our greatest minds. We live in a cosmos that's mostly invisible to us, held together by forces we're only beginning to understand. We're like children who can see the surface of an ocean but have no idea about the depths below. Everything you can see, stars and planets and galaxies, is only 5% of what exists. The rest is mystery. Dark matter, dark energy, invisible forces and substances that shape reality in ways we can barely comprehend. We're surrounded by the unknown, held together by things we can't detect, living in a universe far stranger and more complex than it appears. But even in this vast darkness, there are islands of incredible light, places where matter gathers and ignites and creates the spectacular displays we call stars. Our planet sits in the perfect zone around the sun. Not too hot, not too cold, just right for liquid water to exist on the surface. Scientists call this the habitable zone, but some call it the Goldilocks zone, after the fairy tale about the girl who found porridge that was neither too hot nor too cold, but just right. If Earth were just 5% closer to the sun, the oceans would boil away. Water vapor would fill the atmosphere, trapping heat in a runaway greenhouse effect, like what happened on Venus. The surface would become a scorched wasteland where temperatures reach hundreds of degrees, hot enough to melt lead. Life as we know it couldn't exist. If Earth were just 15% farther from the sun, the oceans would freeze solid. The entire planet would become an ice ball, reflecting sunlight back into space, getting colder and colder until even the atmosphere froze and fell as snow. Nothing could survive, except maybe some hardy bacteria deep underground, huddled around volcanic vents. But we're not in either of those places. We orbit at exactly the right distance, about 93 million miles from the sun. Close enough to stay warm, far enough to stay cool. This perfect positioning has held for billions of years, allowing liquid water to persist on Earth's surface, creating the conditions for life to emerge and flourish. And it's not just the distance. Earth tilts at just the right angle, about 23.5 degrees. This tilt gives us seasons as different parts of the planet lean toward or away from the sun throughout the year. Without this tilt, there would be no spring or autumn, no changing of leaves, no migration of birds. The equator would be unbearably hot, while the poles stayed frozen year-round. Much of the planet would be uninhabitable. Our moon helps too. It stabilizes Earth's tilt, keeping it from wobbling wildly like some other planets do. Mars, for example, has wobbled between 13 and 40 degrees over millions of years, creating dramatic climate swings. But Earth's tilt stays steady because of the moon's gravitational influence, giving us reliable seasons, predictable climate patterns, stable conditions for life to adapt and thrive. Even our atmosphere is just right, thick enough to trap heat and protect us from radiation, but not so thick that it creates crushing pressure or extreme greenhouse warming. It's 78% nitrogen, 21% oxygen, with traces of other gases. That oxygen level is crucial. Much higher, and fires would burn out of control. Much lower, and complex life couldn't get enough to breathe. And we have a magnetic field generated by Earth's liquid iron core. This invisible shield deflects harmful solar radiation that would otherwise strip away our atmosphere and bombard the surface. Mars lost most of its atmosphere billions of years ago because its magnetic field shut down. But Earth's core keeps churning, keeps generating that protective bubble around our planet. This delicate balance has held for 4.5 billion years. Distance, tilt, atmosphere, magnetic field, the presence of water, all working together perfectly. It's like winning the cosmic lottery, and this perfect balance created conditions for something truly special to emerge, something rare and precious in the vastness of space. The water you drink might be billions of years old. Those water molecules have been around since Earth first formed, and possibly even before that. They've been cycling through the planet endlessly, moving from ocean to sky to land and back again, never leaving, never wearing out, just changing form and location in an eternal dance. Water is patient. A water molecule might spend years in the ocean, drifting with currents, moving between surface and depths. Then one day, warmed by the sun, it evaporates and rises into the atmosphere as vapor. It floats with the wind, sometimes for days or weeks, traveling hundreds or thousands of miles. Eventually, it cools, condenses around a speck of dust, joins with other molecules to form a droplet, and falls as rain. Maybe it lands on a mountain. It might soak into the ground, seeping through layers of rock and soil, spending years or even centuries as groundwater before emerging from a spring. Or maybe it flows across the surface, joining a stream that becomes a river that eventually reaches the sea. And then the cycle begins again. This means the water in your glass has traveled everywhere. It's been rain falling on ancient forests. It's been ice frozen in glaciers for thousands of years. It's flowed through rivers that no longer exist. It's been drunk by animals that are now extinct. Dinosaurs drank this water. So did the first humans who walked out of Africa. So did everyone who has ever lived. You share water with all of history. The water that Julius Caesar used to wash his hands might be in a cloud above your city right now. The water that flowed past Cleopatra's palace in the Nile has circulated through the global water cycle and could be anywhere today. Water connects all of time into one continuous flowing story. And it's not just historical. Right now, the same water molecules are being used by countless living things simultaneously through different stages of the cycle. A tree pulls water from the soil through its roots, uses it for photosynthesis, releases it through its leaves. That vapor rises, forms a cloud, falls as rain on the ocean. A fish swims through it. It evaporates again. The cycle never stops, never rests. Water is also a traveler between living things. The water in your body right now came from what you drank and ate recently. Before that, it was in a reservoir, or a river, or underground. Before that, it might have been in plants, in animals, in the soil. You borrow water from the world for a while, use it to stay alive, then return it through breath, sweat, and other natural processes. Then another creature borrows it. Water passes from life to life to life, connecting everything that drinks, or grows, or breathes. There's only so much water on Earth. It doesn't leave the planet in significant amounts. The water that exists today is essentially the same water that's always existed here. It just keeps moving, keeps changing state, keeps flowing through the endless cycle that makes life possible. This ancient substance, older than mountains, older than continents, has been shaping our world since the beginning. But water, isn't the only thing that's been patiently shaping the Earth for billions of years. Mountains that seem eternal are actually young in cosmic time. The Himalayas, the tallest mountain range on Earth, only started forming about 50 million years ago. That sounds ancient by human standards, but Earth is 4.5 billion years old. In the planet's timeline, the Himalayas are practically newborns, and they're still growing, pushed up by continents slowly colliding, rising a few centimeters every year as India continues to press into Asia. Nothing on Earth is permanent. Everything is slowly changing, always moving, constantly being reshaped by forces too gradual for human eyes to notice. Mountains rise, and then, just as slowly, they erode away. Rain falls on peaks, freezing in cracks, expanding, breaking rock apart bit by bit. Wind carries away tiny particles. Rivers carve through stone, cutting deeper year after year, century after century, until massive canyons form where there once was level ground. The Grand Canyon is a perfect example of time's patient work. The Colorado River has been cutting through rock layers for about 6 million years, removing stone grain by grain, carrying it downstream to the sea. 6 million years of constant, gentle erosion created one of Earth's most spectacular landscapes. The river didn't rush. It just kept flowing, kept working, and time did the rest. Even the hardest rock yields to wind and water over millions of years. Granite mountains that seem indestructible will eventually become sand on a beach. That sand might get buried, compressed into new rock, pushed up by geological forces to form new mountains, which will then erode again. The cycle repeats endlessly, rock becoming sand, becoming rock again, continents drifting, mountains rising and falling like slow breaths. Continents themselves move. Right now, North America is drifting away from Europe at about the speed your fingernails grow, roughly an inch per year. The Atlantic Ocean is getting wider while the Pacific is slowly shrinking. Millions of years from now, the map of Earth will look completely different. New mountain ranges will exist. Current ones will have worn down to hills. Coastlines will have shifted. Islands will appear and disappear. And this has been happening since Earth formed. The ground beneath your feet has traveled across the globe. The rock under your city might once have been at the equator, or near the poles, or underwater, or part of a mountain range that no longer exists. Fossils of sea creatures are found on mountaintops because those mountains were once ocean floors, lifted up over millions of years by the slow dance of tectonic plates. Time reshapes everything. Cliffs crumble, beaches grow and shrink. Deltas extend into the sea as rivers deposit sediment year after year. Volcanic islands emerge from the ocean, grow, then slowly sink back down as the plate beneath them moves away from the hot spot that created them. The Hawaiian Islands show this process perfectly. The Big Island is young and still has active volcanoes. The older islands to the northwest are smaller, more eroded, slowly sinking. This transformation isn't just happening on Earth. Every planet, every moon, every body in space is constantly changing, shaped by impacts, by gravity, by heat and cold, by time itself. And this patient transformation isn't just happening on Earth. It's happening everywhere, across the entire solar system and beyond. Every second, the sun converts 4 million tons of itself into pure light and warmth. 4 million tons, every single second. It's doing this through nuclear fusion, crushing hydrogen atoms together with such tremendous pressure and heat that they combine into helium, releasing enormous amounts of energy in the process. This is the power source that lights our world, warms our planet, makes life possible. That light takes 8 minutes to reach us, traveling through the emptiness of space at 186,000 miles per second. Think about that for a moment. When you step outside and feel sunlight on your skin, you're feeling something that left the sun while you were having breakfast, or getting ready for your day, or still asleep in bed. The photon that just touched your face began its journey 8 minutes ago, racing across 93 million miles of space to finally arrive here, to warm you. But before that photon could even start its journey to Earth, it had to escape from inside the sun. And that takes much longer than 8 minutes. A photon created in the sun's core has to bounce around inside the sun for thousands, sometimes hundreds of thousands of years before it reaches the surface. The sun is so dense, so packed with matter, that light can't travel straight through. It gets absorbed and re-emitted over and over, zigzagging slowly outward, taking an incredibly long time to finally break free. So the sunlight touching you right now might have been created in the sun's core before human civilization began. It's been trapped inside that burning sphere, bouncing around, gradually working its way out, until finally it escaped and made that 8-minute sprint to Earth. The warmth on your skin is ancient energy, finally completing its long journey. The sun has been doing this for 4.5 billion years. Every day of Earth's existence, the sun has been there, burning steadily, providing the energy that drives weather, creates wind and rain, powers plants through photosynthesis, and feeds the entire food chain. Without the sun's constant output, Earth would be a frozen, lifeless rock floating in darkness. And it will continue for another 5 billion years. The sun is only about halfway through its life. It has enough hydrogen fuel to keep burning for billions more years before it runs out and begins to die. Eventually, it will expand into a red giant, possibly swallowing the inner planets. But that's so far in the future, it's almost impossible to comprehend. For now, and for an unimaginably long time to come, the sun will keep shining, keep giving, keep converting its own mass into the light and warmth that sustains us. Every sunrise is a gift billions of years old. Every ray of light represents matter, transformed into pure energy, ancient power traveling across space to reach you. The sun asks nothing in return. It just burns, day after day, year after year, millennium after millennium, faithful and constant. There's something deeply reassuring about the sun's reliability. It's been there every day of your life. It was there for your parents, your grandparents, your ancestors, stretching back to the very first humans. It will be there tomorrow and the day after, and for billions of days beyond that. The same sun that warms your face also warms every other face on Earth. But our sun is just one tiny light in an ocean of stars, each one its own sun, burning with the same nuclear fire. When you look at stars, you're looking back in time. The light from those stars doesn't reach you instantly. It has to travel across space. And even though light is the fastest thing in the universe, space is so vast that the journey takes years, sometimes thousands, or even millions of years. The star you're seeing isn't how it looks right now. It's how it looked when that light began its journey toward Earth. The nearest star to us, after the Sun, is called Proxima Centauri. It's about 4 light-years away. That means the light you see from it tonight left that star 4 years ago. You're seeing it as it was 4 years in the past. If something dramatic happened to that star today, we wouldn't know for another 4 years. The light carrying that information is still traveling through space, hasn't reached us yet. Most stars you can see with your eyes are much farther away. Some are dozens of light years distant. Some are hundreds. A few are thousands of light years away. When you look at a star that's 1,000 light years away, you're seeing light that left that star 1,000 years ago, when medieval castles were being built on Earth, when most of the world had never heard of each other, when the night sky looked almost exactly the same as it does now. Some of those stars might not even exist anymore. They could have exhausted their fuel, collapsed, exploded as supernovas centuries ago. But their light is still traveling toward us, still crossing the enormous distances of space. We won't know they're gone until that final light reaches us. So, when you look up at the night sky, you're seeing a mixture of time periods. Some stars as they were a few years ago, some as they were decades ago, some as they were when your great-grandparents were young, some as they were before written history began. It's like looking at an old photograph, except the photograph is being taken by the universe itself, and it takes years or centuries for the image to reach you. The night sky is a time capsule, showing you the past of distant suns spread across thousands of years of cosmic history, all visible at the same moment. And it works both ways. If there are beings on planets orbiting distant stars, looking back at our sun, they're seeing Earth's past. Someone 100 light years away looking at Earth right now would see it as it was in the early 1900s. They'd see a world before computers, before moon landings, before most of modern technology. Someone 1,000 light years away would see Earth in medieval times. Someone far enough away would see dinosaurs walking on a planet that humans don't exist on yet. The universe doesn't have one present moment. It has countless moments, all existing simultaneously, depending on where you're standing and what you're looking at. Time and space are woven together in ways that our daily experience doesn't prepare us for. The farther you look, the farther back in time you see. This gives the night sky a haunting beauty. Those points of light aren't just distant places, they're distant times. Each star is sending its ancient light across the void, a message from the past that takes years or centuries to arrive. We're receiving cosmic letters that were written long before we were born. And in this vast ocean of starlight, something truly magical happens when you look closely at those distant suns. Stars aren't just white dots in the darkness. They're red, blue, yellow, orange, each color telling a story about that star's temperature, its age, its place in the cosmic cycle of birth and death. Look closely at the night sky on a clear evening, and you can see these colors, subtle but real, painting the darkness with a palette most people never notice. The cooler stars glow red. These are often older stars, giants that have exhausted much of their hydrogen fuel and expanded, their surfaces cooling as they spread out. Red stars might seem dim and dying, but many are actually enormous, hundreds of times larger than our Sun. Betelgeuse, one of the brightest stars in the constellation Orion, is a red supergiant so massive that if you placed it where our Sun is, it would swallow Mercury, Venus, Earth, and Mars. Its red glow tells you it's cooler than our Sun, only about 3,000 degrees on its surface compared to the Sun's 10,000 degrees. The hottest stars burn brilliant blue. These are young, massive stars, sometimes dozens of times heavier than the Sun, burning their fuel at incredible rates. Their surfaces can reach 30,000 or 40,000 degrees. They're so hot they glow blue-white, pouring out enormous amounts of energy. But they live fast and die young, while our Sun will burn for 10 billion years. These blue giants might last only a few million years before exhausting their fuel and exploding. Our Sun is yellow, right in the middle of the temperature range. It's what astronomers call a main sequence star, stable and middle-aged, burning steadily. Yellow stars like ours are common in the universe, and they live long enough for planets around them to develop complex life. The Sun's yellow color tells us it's been burning for billions of years and has billions more to go. Orange stars are a bit cooler than the Sun, smaller and dimmer, but they can burn for tens of billions of years because they use their fuel so slowly. Some scientists think orange stars might be the best candidates for hosting life because they're stable for such incredibly long periods, giving life plenty of time to evolve and develop intelligence. These colors exist because of temperature and the physics of light. Hot objects emit light at different wavelengths depending on how hot they are. Heat metal enough and it glows red, then orange, then yellow, then white, then blue, as it gets hotter and hotter. Stars work the same way. Their color is a thermometer, telling you the temperature of their surface just by looking. When you look at the night sky knowing this, it transforms from a scatter of white dots into a tapestry of temperatures and ages. That red star is ancient and cool. That blue one is young and blazing. That yellow one is middle-aged and stable. Each color is a chapter in a star's life story, written in light and visible across light years of space. Astronomers can learn incredible amounts from a star's color. They can estimate its mass, its age, how long it will live, whether it might have planets, what elements it contains. Color is information encoded in starlight, traveling across the cosmos to tell us secrets about distant suns. But these colors reveal something even more profound about the nature of the universe itself. Space itself is expanding, carrying galaxies farther apart from each other. This isn't galaxies moving through space like cars on a highway. Space itself is growing, stretching, getting bigger. It's one of the strangest discoveries in all of science, and it changes everything we thought we knew about the universe. Imagine dots drawn on a balloon. Now, imagine blowing up that balloon. The dots move away from each other, not because they're traveling across the balloon's surface, but because the surface itself is expanding. That's what's happening with galaxies. They're not flying through space. The space between them is growing, pushing them apart. This expansion has been happening for 13.8 billion years, ever since the Big Bang. At the very beginning, everything that would become our universe was compressed into an impossibly tiny point, smaller than an atom. Then it began expanding, and it's never stopped. For billions of years, space has been stretching, growing, carrying matter along with it as it expands. We know this because when astronomers look at distant galaxies, they see something remarkable. The light from those galaxies is shifted toward the red end of the spectrum. This is called redshift, and it happens when something is moving away from you. The farther away a galaxy is, the more its light is redshifted, meaning it's moving away faster. This tells us the universe is expanding, and the expansion is happening everywhere at once. But here's what makes this truly mind-bending. The expansion is speeding up. For a long time, scientists thought gravity would eventually slow down the expansion, maybe even reverse it, causing everything to collapse back together in a big crunch. But observations in the late 1990s showed the opposite. Galaxies aren't just moving apart, they're moving apart faster and faster. Something is pushing space to expand more quickly, and we don't know what it is. Scientists call it dark energy, and it makes up about 68% of the universe. Dark matter is another 27%. Normal matter, everything we can see and touch, is only about 5%. We live in a universe where 95% of what exists is completely mysterious to us. This accelerating expansion means the universe has a strange fate ahead. Billions of years from now, distant galaxies will be moving away so fast that their light will never reach us. The universe will look emptier and emptier as galaxies disappear beyond our cosmic horizon. Eventually, if you were still around, you'd only be able to see your local group of galaxies. Everything else would be too far away, racing away faster than light can travel. But that's billions of years in the future. Right now, we're living in an era where we can still see most of the universe, where galaxies are spread across the sky like islands in an expanding ocean. We're fortunate to exist at a time when the cosmos is still visible, when we can look out and see the vastness of creation before it disperses beyond view. The universe is not static. It's not frozen. It's alive with motion, growing every second, stretching the fabric of reality itself. You're part of something dynamic, something that's been unfolding for billions of years and will continue for billions more. And as the universe expands, it's also revealing its own history, showing us glimpses of how everything began. Ancient light from the Big Bang still surrounds us. It's everywhere, filling all of space, invisible to your eyes, but real and detectable. Scientists call it the cosmic microwave background, and it's like the universe's baby picture, showing what it looked like 380,000 years after birth. That sounds like a long time, but in cosmic terms, it's incredibly young. The universe was still glowing, still hot from its explosive beginning. In those early moments, the universe was too hot for atoms to form. electrons and protons flew around freely, and light couldn't travel far before hitting something. The universe was opaque, like being inside a glowing fog. But as space expanded, it cooled. Eventually, about 380,000 years after the Big Bang, it cooled enough for electrons and protons to combine into hydrogen atoms. Suddenly, light could travel freely. The fog cleared, and that light has been traveling through space ever since. We can still detect that light today. It's been stretched by the expansion of the universe, shifted from visible light down to microwave wavelengths. But it's there. This ancient glow surrounds you right now. It comes from every direction, a faint whisper of radiation left over from the beginning of everything. You're literally bathed in the light of creation, every moment of every day. Scientists first discovered this cosmic background radiation by accident in 1964. Two researchers were trying to eliminate noise from a radio antenna and kept detecting a persistent signal coming from all directions in the sky. They couldn't get rid of it. Eventually, they realized they weren't hearing noise at all. They were hearing the echo of the Big Bang, the oldest light in the universe, still traveling through space after nearly 14 billion years. This discovery confirmed what theorists had predicted. If the universe began in a hot, dense state and has been expanding and cooling ever since, there should be leftover radiation from that early period. And there was. The cosmic microwave background is one of the strongest pieces of evidence we have that the Big Bang actually happened, that our universe had a beginning, that everything emerged from an incredibly hot and dense state billions of years ago. The temperature of this background radiation is incredibly cold now, only about 3 degrees above absolute zero. But that faint warmth is the remnant of unimaginable heat, cooled by billions of years of expansion. It's remarkable that we can still detect it at all, this ancient light that has traveled so far, for so long, finally reaching detectors we built to listen for the universe's earliest whispers. Maps of the cosmic microwave background show tiny variations in temperature, little fluctuations that represent slightly denser or less dense regions in the early universe. These tiny differences grew over billions of years into galaxies, stars, planets, and eventually life itself. The seeds of everything we see today were present in those small temperature variations, frozen in that ancient light. So when you look at images of the cosmic microwave background, you're seeing the structure of the infant universe, the blueprint from which everything emerged. Those tiny ripples of density eventually became clusters of galaxies. And one of those galaxies contains the star we orbit. And one of those planets orbiting that star became home to you. And this ancient light tells us something beautiful about our cosmic family, about the deep connections we share with everything that exists. Every star, every planet, every grain of sand came from the same beginning. We're all made from the same primordial material, just arranged differently. That hydrogen atom in your body and the hydrogen in a star billions of light years away both came from the Big Bang. They share the same birthday, the same origin story. The only difference is how they've spent the last 13.8 billion years. In the earliest moments after the Big Bang, the universe was just energy and the simplest particles. As it cooled, those particles combined into the first atoms, mostly hydrogen with some helium. That's it. The entire universe was basically a cloud of hydrogen and helium spreading out through space. Everything else came later, built from that simple beginning. Stars formed from those primordial clouds. They fused hydrogen into heavier elements. They lived and died and scattered those elements into space. New stars formed from the enriched material, made heavier elements still, died, and scattered them again. Generation after generation of stars, each one adding to the cosmic inventory of elements, building up the periodic table, one explosion at a time. So, the atoms in your body aren't fundamentally different from atoms anywhere else in the universe. They're all descended from that same starting material. The iron in your blood and the iron in a distant asteroid both came from dying stars. The oxygen you breathe and the oxygen frozen in comets both formed in stellar furnaces. We're all made of the same stuff, connected through deep time and shared ancestry. You and the stars share the same birthday. When the universe began 13.8 billion years ago, all the energy that would eventually become you was already there, compressed into that impossibly small point. You've always existed in some form, as energy, as particles, as atoms, as stardust, as molecules in space, as elements in Earth's crust, as nutrients in food, and now as you. The material has been rearranged countless times, but it's never been created or destroyed. It's just been transformed. There's no separation between you and the universe. It's all one continuous expression of the same fundamental reality. The boundary between your body and the air around you is artificial, just a temporary arrangement that will eventually dissolve. You're not in the universe like a marble in a box. You're part of the universe, like a wave is part of the ocean. You emerge from it, exist for a while as a distinct pattern, then merge back into it when that pattern dissolves. This means every person you've ever met is your cosmic sibling. You're all made from the same stellar ash, all descendants of the same ancient stars. The tree outside your window is family. The bird in that tree is family. The microbes in the soil, the fish in the ocean, the insects in the grass, all family. We're separated by evolution and biology, but united by chemistry and cosmic history. Even rocks are relatives. The stones under your feet came from the same source as you did. They just took a different path, arranged their atoms differently, but the atoms themselves are siblings of yours, born in the same stellar fires, scattered by the same supernova explosions, drifting through the same ancient clouds before eventually ending up here on Earth. And this connection goes deeper than just our origins, deeper than chemistry and physics. For billions of years, the universe existed without anyone to observe it. Stars burned, galaxies formed, planets orbited suns. But there was no consciousness, no awareness, no one to witness any of it. The cosmos went about its business in darkness, unseen and unknown, following the laws of physics, with no one around to appreciate or understand them. Then, slowly, something remarkable happened. on at least one planet, orbiting one ordinary star in one typical galaxy, simple chemicals began organizing themselves in increasingly complex ways. Molecules formed that could copy themselves. Those molecules evolved into cells. Those cells eventually learned to work together, forming larger organisms. And over billions of years of gradual change, some of those organisms developed nervous systems complex enough to produce consciousness. Awareness emerged. For the first time, the universe could experience itself. Through your eyes, the cosmos sees its own beauty. Through your mind, it contemplates its own existence. You are how the universe knows it's here. You are the mechanism by which unconscious matter becomes conscious of itself. This is not poetry or metaphor. This is literally what's happening. The atoms that make you up are the same atoms that make up stars and planets, but arranged in such a specific, intricate way that they can think and feel and wonder. You're not separate from nature observing it from the outside. You're nature observing itself from the inside. When you look at a sunset, it's the universe appreciating its own light. When you feel awe at the night sky, it's the cosmos feeling wonder at its own vastness. The observer and the observed are made of the same substance, connected by unbroken chains of cause and effect stretching back to the beginning. This makes consciousness incredibly precious. For most of cosmic history, none of this was seen or appreciated. Black holes swallowed stars, and no one noticed. Supernovas exploded in spectacular displays that went unwatched. Galaxies collided and merged in slow-motion ballets that played out over millions of years with no audience. All that beauty, all that grandeur existed without witness. But now there are witnesses. Now there are beings scattered across Earth, maybe across other planets too, capable of understanding what they see. Every human who has ever gazed at stars and wondered about them represents the universe becoming conscious of itself. Every scientist studying cosmic mysteries is matter using the laws of physics to understand the laws of physics. The universe is examining itself through us, and you are part of this great awakening. Your awareness right now, reading these words, thinking about the cosmos, that's the universe experiencing a moment of self-reflection. Your thoughts are the universe thinking. Your wonder is the universe wondering. You're not a tiny, insignificant thing lost in vast emptiness. You're how the vastness knows it exists. There might be countless other conscious beings scattered across billions of planets in billions of galaxies. Or we might be rare, special, one of the few places where matter has organized itself into awareness. Either way, consciousness matters. It transforms the universe from a collection of unconscious processes into something that can know itself, appreciate itself, find meaning in itself. And this awareness reveals something comforting about our place here, something that makes existence feel less random and more purposeful. The odds of you existing are astronomically small, yet here you are. Think about everything that had to happen for you to be reading these words right now. The universe had to begin. Stars had to form and die, creating heavy elements. Our solar system had to coalesce from ancient stardust. Earth had to form in the perfect location. Life had to emerge from chemistry. Complex organisms had to evolve. Your ancestors, going back millions of generations, had to survive long enough to have children. Every single one of your ancestors, stretching back to the first single-celled organisms billions of years ago, survived to reproduce. Not one of them died too young. Not one failed to find a mate. An unbroken chain of survival and reproduction, billions of years long, led to you. If any link in that chain had broken, you wouldn't exist. Someone else might, but not you. Not this specific arrangement of atoms and experiences and thoughts. Your parents had to meet at exactly the right time. A different day, a different conversation, and you might never have been conceived. And their parents had to meet, and their parents before them. Go back far enough, and you realize that tiny changes in history, a storm that delayed someone's journey, a chance encounter that led to a marriage, could have prevented your existence entirely. Even the specific combination of your parents' DNA that created you was unlikely. Your parents could have had millions of different children, depending on which cells combined. But they had you. This particular arrangement of genes, this unique pattern, happened once and will never happen again. You are unrepeatable. There has never been anyone exactly like you, and there never will be again. This moment right now is also unique. It has taken 13.8 billion years to arrange. Every event in cosmic history, from the Big Bang to this second, has led here. The formation of galaxies, the birth of stars, the creation of planets, the emergence of life, the evolution of consciousness, all of it building toward this moment where you exist and can appreciate your own existence. You're experiencing something that has taken the entire age of the universe to create. This isn't just your life. This is the culmination of everything that came before, all of cosmic history converging on this point where you can think and feel and wonder. The universe spent billions of years preparing the conditions for your awareness. And this moment will never come again. Right now, you're this specific age, in this specific place, with these specific thoughts and feelings. Tomorrow, you'll be different. Your cells will have replaced themselves. Your memories will have changed. Your perspective will have shifted. The you that exists right now is temporary, a brief arrangement that will never be exactly duplicated. There's something both sobering and beautiful about this. It makes every moment precious because it's unrepeatable. It makes your existence miraculous because it's so unlikely. Against all odds, despite the vast improbability, you're here. The universe managed to arrange itself in such a way that you could exist, that you could be conscious, that you could experience this moment of wonder. But while this moment is unique, you're also part of something eternal, something that transcends this brief arrangement of atoms and experiences. The first law of thermodynamics states something profound. Energy cannot be created or destroyed. It can only change form. This means the energy that makes you who you are has always existed and always will. It's been here since the beginning, and it will be here at the end, if there is an end. You're not a temporary phenomenon, appearing from nothing and disappearing into nothing. You're a temporary arrangement of eternal stuff. Right now, energy flows through you constantly. You take in energy from food, from sunlight absorbed by plants that you eat, or that feed animals you eat. That energy powers your cells, fuels your thoughts, keeps your heart beating, maintains your body temperature. Then you release energy back into the world as heat, as motion, as the work of simply being alive. The energy comes in, transforms, and goes out, but it never disappears. It just changes. When you move, you're converting chemical energy stored in your muscles into kinetic energy and heat. When you think, you're using electrical and chemical energy in your brain. When you speak, you're creating sound waves, transferring energy into the air around you. Every action you take is energy-changing form, following pathways established by the laws of physics, pathways that have existed since the universe began. The atoms that make you up will eventually separate. Your body will break down, return to the earth, get absorbed by plants and animals, continue cycling through the biosphere. But the energy that animated you, that made you conscious and alive, doesn't vanish. It transforms. It becomes heat. It becomes the energy used by other organisms. It radiates into space. It continues existing in different forms. This means that in a very real sense, nothing truly ends. Everything transforms. The universe doesn't waste anything. Every atom gets reused. Every bit of energy gets recycled. You're part of this eternal cycle, this endless transformation of matter and energy that has no beginning or end, just constant change. Ancient philosophies intuited this truth long before physics proved it. The idea that nothing is born and nothing dies, that everything just changes form, appears in spiritual traditions around the world. Now we know it's not just philosophy, it's physics. The conservation of energy is one of the most fundamental laws of nature. It means the essence of what you are cannot be destroyed. Your specific pattern, the arrangement of atoms and energy that creates your consciousness and personality, is temporary, but the substance is eternal. The atoms that make you up are billions of years old. The energy flowing through you has been flowing since the Big Bang. You're a brief ripple on an infinite ocean, a temporary wave that rises and falls, but the ocean continues. This offers a strange comfort. You're not fighting against the universe's tendency toward disorder. You're part of its creative expression, one of countless patterns it forms and dissolves and reforms. Your existence matters not because it's permanent, but because it's part of this grand transformation, this cosmic dance of energy and matter constantly rearranging itself into new forms. The universe has been doing this for billions of years, creating patterns, dissolving them, creating new ones. Stars form and explode, planets coalesce and break apart. Life emerges and evolves and goes extinct. But nothing is lost. Everything transforms. And this eternal nature points to something deeply peaceful about existence itself. Everything moves in cycles. Day turns to night, turns to day, again. Seasons flow from spring to summer to autumn to winter and back to spring. The moon waxes and wanes, appearing full, then vanishing, then reappearing. Tides rise and fall twice daily, responding to the moon's pull. Birth leads to growth, leads to aging, leads to death, which provides nutrients for new birth. The universe breathes in patterns, rhythms that repeat endlessly across all scales. Stars follow this rhythm too. They're born from clouds of gas and dust that collapse under their own gravity. They ignite, burn steadily for millions or billions of years, then die. Small stars fade slowly into white dwarfs, cooling embers that will glow faintly for trillions of years. Massive stars explode as supernovas, scattering their enriched material back into space. And from that scattered material, new stars form. The cycle continues, generation after generation, stars being born from the ashes of their predecessors. Even galaxies have cycles. They collide and merge, forming larger galaxies. Stars form in bursts of activity. Then the galaxy quiets down. Then new waves of star formation begin. Black holes at galactic centers consume matter, then go dormant, then consume again. Nothing in the universe is static. Everything pulses with activity, follows patterns of creation and destruction and creation again. Your own body lives by cycles. Your heart beats in rhythm. Your lungs expand and contract. You wake and sleep. Cells are born, live their span, then die and are replaced. Hormones rise and fall throughout the day. Your brain cycles through different states during sleep, each one serving a purpose. You're not a fixed thing. You're a process, a pattern of activity that continues because of these cycles. Nature shows us that endings are not failures. They're necessary parts of the cycle. Autumn leaves don't fail when they fall. They're completing their purpose, returning nutrients to the soil so new growth can happen in spring. Winter isn't the death of nature. It's a rest period, a time when energy is conserved and prepared for the explosion of life that comes with warmth. This rhythm teaches something important. There's a time for activity and a time for rest, a time for growth and a time for letting go. Fighting against this natural rhythm creates stress. Accepting it brings peace. You don't have to be productive every moment. You don't have to grow constantly. There are seasons in human life too, times to push forward and times to pull back, times to build and times to release. Right now, you're in the rest part of the cycle. Your body is preparing for sleep, slowing down, shifting into repair mode. This isn't laziness or weakness. This is necessary. Sleep is as important as waking. Rest is as valuable as action. The universe itself has rhythms of activity and quietude, and you're following that same pattern. Breathing is the most fundamental rhythm. In and out, endlessly, your whole life. Each inhale brings in oxygen and energy. Each exhale releases carbon dioxide and tension. It's a perfect cycle, each part necessary, neither one better than the other. You can't only inhale. You can't only exhale. the rhythm requires both. And as you drift towards sleep, remember this final beautiful fact about your place in this vast rhythmic universe. Right now, you're connected to everything. The ground beneath you, the air around you, the cosmos above. These aren't separate things you happen to be near. They're part of the same continuous system that includes you. The boundary between your body and the world is softer than it seems. Air flows in and becomes you. Food becomes you. Water becomes you. And you become air and earth and water again. The exchange never stops. Gravity connects you to everything with mass. Right now, you're pulling on the earth with the same force the earth pulls on you. The pull is tiny because you're small compared to a planet, but it's real. You also pull on the moon, on the sun, on distant stars, and they pull on you. Every atom in the universe exerts gravitational force on every other atom. Nothing is isolated. Everything tugs on everything else across the vastness of space. The same forces holding stars together are holding you together. Electromagnetic force binds electrons to atoms, atoms to molecules, molecules to cells. This is the same force that makes stars shine, that powers lightning, that creates the auroras dancing in polar skies. You're operating according to the same rules as everything else in the cosmos. The laws that govern galaxies also govern your heartbeat. You're surrounded by ancient light. Photons from the sun, 8 minutes old, warm your skin. Starlight that traveled for years or centuries enters your eyes. The cosmic microwave background, nearly 14 billion years old, passes through you constantly. You exist in a bath of radiation from near and far, from recent and ancient sources, all of it carrying information about the universe. Even the elements in your body connect you to distant explosions. The calcium in your bones was forged in a supernova that happened before Earth existed. The iron in your blood came from a dying star billions of years ago. You carry the remnants of cosmic violence, transformed into something gentle, something alive. Every breath you take includes atoms that have been breathed by countless other beings throughout history. The universe has spent billions of years preparing this exact moment for you to rest. The formation of stable atoms after the Big Bang. The creation of heavy elements in stellar furnaces. The birth of our solar system. The development of Earth's atmosphere. The evolution of life. All of this, billions of years of cosmic history, led to right now, to you lying here, safe and comfortable, able to contemplate your place in this vast story. You're cradled by gravity, the same force that holds planets in orbit and binds galaxies together. You're warmed by nuclear fusion happening in the sun's core, the same process that lights every star. You're made of stardust, atoms forged in cosmic fires and scattered across space. You're conscious matter, the universe's way of knowing itself. And right now, you're participating in the most natural rhythm of all, the cycle of waking and sleeping, activity and rest. As you drift into sleep, know that you're held by something vast, ancient, and infinitely patient. The universe itself, watching over you as you dream. If this journey brought you peace tonight, hit that like button and subscribe so we can explore more cosmic wonders together tomorrow. Leave a comment about which fact amazed you most, and sleep well, knowing you're part of something beautiful, something eternal, something that will continue long after this moment fades. Sweet dreams, cosmic wanderer.